Okay, so this video is going to start looking at vector functions and creating a Cartesian equation for a function that's given in terms of t. So we're going to actually do some questions straight from the textbook here. We're going to look at question 2a, and in these questions we have to find the corresponding Cartesian relation. That's basically find the Cartesian equation in terms of y and x, and state the domain and range of the relation and sketch the graph. Okay, so we will start with question 2a here, and the first thing I'm going to do is I'm going to identify what the x part is and what the y part is. So I'm going to let whatever the function is in front of the I value be my x of t, and whatever the function in front of j is be y of t. So that allows me to write that x equals 2 cos t and y equals 3 sin t. Now the hint that I gave you in our notes is when my x function and my y functions are trigonometric functions, then what I usually end up doing is using a trig identity to turn this into a Cartesian equation. And in this particular case, when I have sine and cos, I always end up using the trig identity that sine squared theta plus cos squared theta equals 1. Sorry, had a moment there. Okay, so what that means is to do this, I'm going to rearrange the x and the y values here. I'm going to rearrange this expression and this expression to get a sine and a cos, which is really pretty straightforward. So for my x term, I'm going to say that x on 2 is the same as cos t. And I'll go one step further. If I square that, I get x on 2 squared is the same as cos squared t. Alright, now work with my y function. I can say that y on 3 is the same as sin t, and in which case y on 3 squared is the same as sin t squared. So now if I substitute this, oops, I missed the squared there. Let's just put that in there before I go any further. If I substitute the y on 3 squared in for sine squared, and I substitute the x on 2 squared in for cos squared, it looks like this. And now I've got a Cartesian equation with just x's and y's in here. And what you might notice is this is actually the equation for an ellipse. So it's an ellipse. It hasn't moved left or right. So there's no translations, and the y-axis intercept, the y axis is going to have a radius of 3. Now I don't think radius is quite the right term, but I'm going to use it anyway. And the x-axis is going to have a radius of 2. So if I want to sketch that graph now, it's going to look like this. So my y-axis is going to go up 3 places and down 3 places. My x-axis is going to go out 2 and back 2. And we should label these points. So that's 2, 0, 0, 3, negative 2, 0, and negative 3, 0. Oops, I mean 0, negative 3 for that last one. Let's write our coordinates the right way around. Okay, and that's the Cartesian equation. I'm actually going to make it y squared on 9 plus x squared on 4 equals 1. Okay, let's go back and check we've read the whole question. So for each of the following vectors, find the corresponding Cartesian equation. Tick, we've got our x and y part. State the domain and the range of the relation and sketch the graph. Okay, let's have a little bit more of a talk about the domain and the range. Now that we've got our graph, I can really clearly see that the domain is going to equal -2 to 2, and it's inclusive, and the range is going to equal -3 to 3, inclusive. But we can get this same value right back from the original function that I set up for x and for y. So from here, what I know is that the x values, they give me the domain. So whatever the possible outcomes are for my x function, that will give me the domain, and whatever the possible outcomes are for the y function, that'll give me the range. So if I think about my, let's highlight this a different colour. If I think about my x function here, that's the graph of 2 cos t. So if we think about the graph of 2 cos t really quickly, 2 cos t, it's a cos graph, it goes like this, and it's going to have a maximum of 2 and a minimum of 2. So the minimum of -2. So the outcomes for that graph, or the range of that graph, is really simply -2 to 2. And the range of the x function becomes the domain of the Cartesian relationship. And then same for my sine graph. Let's change colours here. Let's make this one purple. So there's my y function. If I draw a really quick graph of that, it looks very similar to the one above, except it's a sine graph. It's going to go on forever in each direction, and it will go as high as 3 and as low as -3. So the range of this graph is from -3 to 3, and that becomes the range of my Cartesian equation. So we can find the domain and the range based on whatever my functions of x and y are. Okay, let's have a look at part B now. So part B, and my function, I'm going to rewrite it because we won't always see it on the screen. 2 cos squared ti, 2 cos squared ti plus 3 sine squared tj. And my kids have just come home, so they're just making a lot of noise at the moment, so ignore them in the background. No, I don't want it to equal 1. I'm just going to have to stop this video because they're going to drive me nuts.